Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present our public project which is rainwater harvesting system. Nowadays, water crisis has grown to a critical level, causing billions of people lack access of safe water. So we try to come up with a plan to design and develop a green technology that can conserve water supplies. So we decide to develop a rainwater harvesting system in public school. In this public project, we apply engineering economic analysis so that we can know all the pros and cons as well as the risk, benefit, and cost. For the first objective, we can implement effective water management because we reduce the usage of water supply for non-potable use. Secondly, we can enhance water resilience in public school. This is because this project provide a backup of water source that can be used if there is any disruption or maintenance. Thirdly, we can encourage practical and creative sustainability solution. Moreover, we can involve students in applied learning. This is because students can see how engineering can help in our environment. And lastly, promote scalable and replicable design. So this project can be modeled for other public institutions to create more efficient system.
So basically, there are five important tasks in this project management, which is first, project initiation and planning, second, resource acquisition and team building, third, implementation of recovery systems, fourth, quality assurance and monitoring, and lastly, marketing. There are nine important roles in this project. Firstly, the project manager. Second, civil engineer. Third, environment engineer. Fourth, data analyst. Fifth, procurement officer. Sixth, construction superior. Seven, financial officer. Eight, school representative. And lastly, maintenance office. Okay, so our project, we will be doing around 42 weeks. So as you can see here, to further inspections, we have calculated the ideal budget for this project is around 15,000 ringgit, which consists of survey and designs, approvals and permits, materials, calculation, equipment rental, system integration, training materials, monitoring tools, and lastly, contingency. Also, as you can see here, we have created three different alternatives for this project, which is alternative A, B, and C. And based on the the table here, we have concluded that alternative B is the most ideal one because the budget cost ratio exceeds 1, which means that the benefit exceeds the cost, which means that this project is acceptable.
For the resource allocation method, for the human resources, we use critical path method for the engineers so that we can allocate them early in our project. And then we pay our human resources using skill-based wages. And then for the materials, we use just-in-time procurement, which is we only purchase what we need. And then for the equipment, we share the tools during the installation process. And then for the training resources, we distribute manuals only after installation of the uh, system. And then for the monitoring resources, we install sensors post-construction, and then we keep the 10% extra supplies in case anything happen in the future. And then for the resource allocation plan, for the human resources, we assign each role with related tasks due to their specialties. And also, uh, for the material, we order items 2 weeks early so that there will be no delays during the installation phase later. And then for the equipment, we inspect tools every day. We track the usage so that there will be no losses of the items and equipments. And then for the training resources, we prepare the training modules in advance. and we keep the manuals in school's office. And for the monitoring resources, we plan to for the technician to teach some selected stuff on how to monitor the system. So this is the project schedules that we generated with the work breakdown structure and the Gantt chart in the Microsoft project. This is the continuous from the previous slide, and this is also the continuous from the previous slide also. For the implication on the organizational impact, um, it save water costs for the school from 30 to 50% of reduction in these bills, and then it also requires staff training for the maintenance, and also the school can integrate the practical environmental learning into the curriculum of the school itself. And then for the societal impact, it teaches this project teaches on water conservation. But the challenges is that this project needs high upfront costs in order to execute this project. Last but not least, the conclusion. This rainwater harvesting project successfully reduced the school's water cost by 30 to 50%, while it's supporting the SDG 6, the clean water, and also SDG 4, which is the quality education. And then this project balances immediate water savings with long-term educational benefits, creating lasting value for both the school and also the community.